Top of the morning to you, laddie and lasses. Here we are, coming live from Dublin, of course.
Yes.
Just a quick trip. We figured we'd run out, see how things are going.
University of Dublin.
Yes, since it's probably about 1 in the afternoon there.
I have
Something
no
like that.
idea what the time
So
change is.
here we are. We already introduced you to the mole, and today we're going to take a look at how to take that mole and use the gram amount and convert it into moles and back and forth.
Okay, cool. Because the mole by itself is kind of meaningless if we can't convert in and out of it, right?
Right, exactly. So let's take a look. Okay, again, we have our mole in a jar because it's a mole in a jar. So, all right. So why do we convert? Well, we want to be able to go from one unit to another. Okay. So what we have is, I like to call this the mole roadmap, if you will.
Ooh.
Okay, and as you can see, the arrows are yellow because I like to follow the yellow brick road.
Oh, that's cute. It's adorable.
So you'll get a copy of this, but anytime you're converting from one unit to another, you start by putting your finger on the unit that you start with. So if I'm starting with grams, I'm going to put my finger there, and then I follow the yellow brick road around to moles to figure out what my conversion factor is going to be.
Okay, so I'm going to put my finger on one of the 3 big boxes in the middle.
Correct.
And then I just follow the arrow and type in to my calculator what's on the arrow.
Absolutely. It's very, very easy for you.
Fantastic.
Okay, so let's take a look. Oh, I already got my chart ready now, apparently.
You are excited.
Okay, so first problem we have, it says, how many moles are there in 30 grams of carbon? Now, we don't know.
I don't know.
So what I always like to do with our problem first is I like to circle my unknown, so what I'm trying to find, which is moles, and then I underline what I'm looking for, or what I start with. I'm so sorry.
There you go.
So I'm starting with 30 grams of carbon. Whatever I underline goes in the first spot of my chart.
Excellent.
Okay? So I write 30 grams of carbon.
Okay, and we're ignoring those purple
purple slashes for right now, yes. Okay. So in the next step then, I find what the molar mass of carbon is, which we figured out in the last video. You just go to the periodic table and figure out what 1 mole of carbon is.
12.
Yes. So that goes on the bottom because I need to get rid of my units of grams.
And the way it works out is if they're diagonal from each other, they'll kind of cancel each other out.
Absolutely. As you can see with the pink lines crossing out the grams of carbon.
Gotcha. So the pink lines are the crossies.
Absolutely. So then those are canceled. And then all I do now is anytime I see a vertical line, I multiply. Anytime I see a horizontal line, I divide.
Okay.
So I would take 30 times 1, which we all know is going to be the same, so I don't even necessarily have to do it. But I'll take 30 times 1, which is 30. And then I'll divide by 12, which is on the bottom, to get 2.5 moles of carbon.
Excellent. I tell my kids, multiply all the top numbers, divide by all the bottom numbers.
Absolutely.
Exactly the same thing.
Okay, so let's try another one. It says, how many moles are there in 56 grams of beryllium?
Fun.
So again, we want to circle our unknown, and we're going to underline our known. Okay?
Fantastic.
Then, of course, we take our known and we place it into the first spot in the T-chart.
Boom.
Which was 56 grams of beryllium. Okay, I do my T. Okay, and then on the bottom, I look up beryllium on the periodic table, and I know that it's 9 grams for every 1 mole. Okay.
Okay.
So again, they cancel out the units, multiply across, divide by the bottom, and I get 6.22 moles of beryllium.
That sounds great.
Yes. For the sake of keeping the numbers fairly similar, in my class, we're just going to round to 2 places after the decimal.
Love it.
So nice and easy. What is that, the 100th place?
I believe it is.
Okay.
Yeah, 10ths, 100ths.
My math teacher would be proud. Shout out Mr. Sennett. Okay. So how many grams are there in 4.7 moles of neon?
Whoa. That's a little bit different, huh?
It is a little bit different. So what did we do here this time, Mr. Wood?
Well, it looks like we're looking for grams, and we have moles. So it's the flip-flop.
It's going to be the flip-flop. So when we write this now, we have to flip our conversion factor.
Whoa.
So again, we would put our finger on moles, since that's what we started, and we would follow it around to grams, and it would tell us. So when we put this in, we still start with what we know, 4.7 moles of neon. Tee it up, I like to call it. Sometimes it just makes it a little more exciting.
Yeah,
Okay.
I'm already pretty excited. Yeah,
right?
It's amazing.
And then I would write my conversion factor. So now this time moles goes on the bottom because I have to get rid of the moles I started with.
Gotcha.
And we always know that for no matter the weight of any element, it's always for 1 mole. So the 1 mole goes on the bottom, and then the 20.2 grams of neon is on top. Then I do what I've been saying since the beginning, multiply across, divide by everything on the bottom, which is 1, so it's easy. So I get 94.94 grams of neon.
There you go.
Okay.
Awesome.
Yeah, I think I have one more example of a gram problem.
Ooh, you do.
So, how many grams are there in 3 moles of sulfur? So again, circle the grams, underline what I'm starting with. I'll put it up in the T-chart. Okay, start with 3 moles because that's what I started. They gave me. Tee them up. I put in my 32.1 grams goes on the top. My moles on the bottom because that's what I'm starting with. Gotta get rid of it. And then I simply multiply across and divide by the bottom.
Is that simple?
Very, very easy. Okay. Well, we have to get back to this celebration of the St. Patty's Day, people.
Yep.
So, how do you say goodbye in Irish?
I don't even know how to say hello in Irish.
I don't either. All right.
Bye.
Bye.